Alright, John, so I haven't seen you in a couple of days now, so what I think I'm going to do today is I've already gone through all the information for Chapter 10, so you should be able to take that test at this point. There's a quiz and a test, actually, that you need to take both of those. But because I haven't seen you, I don't really know if you have any questions with anything, so what I'm going to do right now is I'm going to go through. You can see the outline for Chapter 10 right here. So I've gone through all these notes right here so far. I'm just going to take the time for the first probably hour, less than an hour, and go through all the answers for homework 81 through 83. That way I know that you have those answers, and I know that if you're at least having a question, then you can see how I went through and did those problems. So I'm going to do all of those out, and then the second half, or the second hour of these, I'm going to continue on with the notes for Chapter 11. Okay, so next time I talk to you, hopefully you'll be good for Chapter 10. You can take that test, and then we can move on for Chapter 11. Because you have to make it all the way through Chapter 16. Your notes only go up to Chapter 14, because that's where the class was when I started tutoring you. But right now, they're in Chapter 16. So still just a little bit nervous that you're going to be able to make it through all this stuff. So let's do homework number 81 first. Okay, let's do homework 81. And homework number 81 is in the workbook, page 354, numbers 1 through 11. So grab your workbook and we can do these together, okay? So 354, numbers 1 through 11. Number 1, you have to go through and write each expression as a single function or a constant. So you know what, before I even start doing this, what I want to do is take a second and just review all of the identities that we have learned from this chapter. All of the identities that you need to know. Okay, so we have the quotient identities, and the quotient identities are cosecant is 1 over sine. I'm sorry, I should be putting a theta in there for all of these. 1 over sine theta. Secant is 1 over cosine theta. And cotangent is 1 over tangent theta, except for we don't really use that often. But it's just still helpful to know. Those are all of your quotient identities. And then we have the, those are all the reciprocal identities. The quotient identities are tangent theta is equal to sine over cosine. And cotangent is the one that's the reciprocal, or the opposite of that, and it starts with a C, so we know that we have that C up on top. Cotangent is cosine theta over sine theta. Okay? Okay, so reciprocal identities, quotient identities, and now we have the Pythagorean identities. And the Pythagorean identity, the one that you should know right off the top of your head, is sine squared theta plus cosine squared theta is equal to 1. Okay, but there are two different ways that we could rewrite this one equation. We can write this as 1 minus cosine squared is equal to sine squared, because these two are the forms that you're going to see more often than that original one. And then the other one is 1 minus sine squared theta is equal to cosine squared theta. That's what you're going to see in homework questions more frequently, and probably on the test as well. Okay? That's your first Pythagorean identity. And then from that, what we can do is we can derive two other Pythagorean identities. And what we do is we can use this one to derive another one. And what we do is we go through and we divide everything through by sine, and that's going to give us our second identity. And then we go back through and divide everything by cosine, and that's going to give us our third. So let's just divide everything by sine squared. And I'm just going to write s underneath all of them because it's too hard to write out all of these things. So sine squared theta divided by sine squared theta is equal to 1 plus cosine squared theta divided by sine squared theta. That is, cosine over sine is right up here. That's cotangent squared theta because everything is squared. Well, it should be if I was writing it out the full way. And then is equal to 1 over sine gives us cosecant squared theta. I always remember this identity because it has, both of those terms have c's in them, but you can remember it however you want. And then, so that's our second identity. And then the third one, what we're going to do is go through and divide everything by cosine squared theta. So you can do this on your test. Sine squared divided by cosine squared is tangent squared theta. Cosine squared divided by cosine squared is equal to 1. And 1 over cosine squared is secant squared theta. So those are all of the identities, all of the equations that you could possibly need to complete this test. Okay, so as long as you have those written up top on your sheet of paper when you're doing this, you should be fine. Now you see how I rearranged this equation to be 1 minus cosine and 1 minus sine. Well, you can do the same thing for these as well. You could do cosecant squared theta minus cotangent is equal to 1, or secant squared minus tangent squared is equal to 1. You can do things like that, but I'm not going to write them all out because it's more than likely you're going to see them in this form, and I know that you're smart enough to figure that out on your own. So let's go back, and for number 1, we need to rewrite 1 minus cosine squared theta as a single function or constant. And so what I'm going to do is I see a 1 and I see something squared, so I'm going to go over to my sheet. 1 minus cosine squared theta is right here, and that is just equal to sine squared theta. So this is equal to sine squared theta. See, it's not that bad. Number 2. Sine theta times cosecant theta. We want to try to rewrite this. And now you should remember what I said last time. Sine and cosine are our most basic elements. We want to write everything in terms of sine and cosine. So sine theta I can just write as sine theta over 1 because the two terms are being multiplied together. And then cosecant is actually the reciprocal of sine, so 1 over sine theta. And then you can see that because I have a sign on the top and a sign on the bottom, they just cancel out, and this whole thing is actually equal to 1. You could have recognized that up top right away because any function multiplied by its inverse is actually going to be 1 anyways, but if you didn't recognize that right away, you could write it out. Number 3. Tangent theta times cotangent theta. Well, hopefully you recognize from the question above that tangent and cotangent are both, they are reciprocals of one another, so when you're multiplying those together, tangent times 1 over tangent, that's just going to give me 1 as well. It's pretty easy. Okay, number 4. Secant squared theta minus 1. Well, I see a secant squared theta and I see a minus 1, so I'm going to come over here and I see secant squared theta right here. If I subtract that 1 over to the other side, I'm going to be left with just tangent squared theta on that side of the equation, so this whole thing is equal to tangent squared theta. So see how having those written out is really easy because we can just go back right away and identify what we need and what we're missing. Okay, number 5. Tangent times cosecant theta. So what I'm going to do is I'm going to write this out in terms of sine and cosine. So tangent is sine over cosine, and cosecant is 1 over sine. And I see that I have a sign on the top and a sign on the bottom, so I'm going to cross these out. And this becomes 1 over cosine, but 1 over cosine is really just secant theta. Okay. Number 6. See how much time I have left. Oops. 5 more minutes. Okay. Number 6. Alright, this one is a little bit tricky. I'm glad that we're going over it because fractions always make things more difficult. I have cosecant x divided by secant x. So I'm going to do the same thing. I'm going to express everything in terms of sine and cosine. Sorry, Abby is texting me. Cosecant is 1 over sine. And I'm going to write this as a complex fraction with a fraction in the numerator and a fraction in the denominator. Secant is 1 over cosine. So how can I simplify this? Well, I need to multiply by the reciprocal fraction of whatever is in the denominator. So this is cosine over 1 in the top, and the bottom cosine over 1. And you can see that everything cancels out in the bottom, but nothing's going to cancel out on top. So this actually becomes cosine over sine. Cosine over sine can be rewritten as cotangent x. Okay? Number 7. Cosine theta times tangent squared theta plus 1. Well, what do you recognize? Whenever I see something that's squared, I'm going to immediately go back to my reference sheet, or what you write on your test, and say, alright, tangent squared theta plus 1, that's equal to secant squared theta. Good. So, this inside the parentheses is really just equal to secant squared theta. So I have cosine theta times secant squared theta. And then I'm going to go ahead and rewrite everything in terms of sine and cosine. Cosine is just cosine over 1 because I know I'm going to be multiplying. And secant squared is 1 over cosine squared. So I have 1 cosine up here, 2 cosines down here, so I'm left with 1 over cosine, and 1 over cosine is the same thing as just secant. So the answer is secant theta. Okay? Number 8. And if I'm going too fast, you can always just pause this video or rewind it and keep going back. Alright, number 8. Sine squared theta plus cotangent squared theta plus cosine squared theta. So a lot of kids in your class had a little bit of difficulty with this because I see sine squared theta and cosine squared theta, and they're not right next to each other, but it doesn't even matter that they're not right next to each other because sine squared theta plus cosine squared is just theta is equal to 1. So this is really just 1 plus cotangent squared theta. Now I see a 1 and I see something squared, so I know it's another Pythagorean identity, and I'm going to go back to my sheet, take a look at which one it is. 1 plus cotangent squared theta is really equal to cosecant squared theta. So number 8 is really just equal to cosecant squared theta. And I also kind of knew that because when we were writing these out, I told you that the easy way to remember that one is that that identity has you know, a C here and a C here. I don't know if that helps you, but that whole thing is equal to cosecant squared theta.